Good day, everyone. I'm Joseph Kurt A. Bores, and I will report real options. So, what are the objectives of real options? So, let's define the meaning of real options, know the different types of real options, know how businesses use this as a tool in determining whether they will make investments or not, and explain why real options explores the potential of new products or technology in the market. Real options. It is the right but not the obligation to take some action in the future. So this involves tangible assets such as land, building, machineries, instead of financial instruments like bonds or stocks. So the ability to expand or set out an asset is a real option. Unlike financial instruments, after you purchased it, there is no effect in your assets, or it is a passive investment. So there are types of real options. These are growth option, abandonment or shutdown option, investment timing option, and flexibility option. So growth option. A project can be expanded if demand turns out to be stronger than expected. The option to develop follow-on projects, expand markets, expand or retool plants, and so on, that would not be possible without implementation of the project that is being evaluated. So if a project is being considered has the measurable potential to open new doors if successful, then recognition of the cash flows from such opportunities should be included in the initial decision process. Growth opportunities embedded in a project often increase the net present value of the project in which they are embedded. Here is a sample problem. Martin Development Company is deciding whether to proceed with Project X. The cost would be $9 million in year zero. There is a 50% chance that Project X would be hugely successful and would generate annual after-tax cash flows of $6 million per year during years 1, 2, and 3. However, there is a 50% chance that Project X would be less successful and would generate only $1 million per year for the 3 years. If Project X is hugely successful, it would open the door to another investment, Project Y, that would require a $10 million outlay at the end of year 2. Project Y would then be sold to another company at a price of 20 million at the end of year 3. Martin's WACC is 11%. If the company does not consider real options, what is the Project X NPV? As we can see, there is a table of Project X not considering the real options. So we have this hugely successful and less successful for the project, and both of them have probabilities of 50%. In year 0, there is an investment of 9 million, so we put there negative 9. And by the way, these are dollars in millions. So at the end of each year, hugely successful would generate 6 million a year, while if the project would be less successful, they would only generate 1 million per year. So we get the NPV of both parties at 11%. So for the hugely successful, we get 5.662, and for the less successful, we get negative 6.556. And then we total them, we get negative 0.894. There is a 50% probability that the Project X would be hugely successful and Project X would be less successful. So we multiply it by 50%. Now we get the expected NPV at negative 0.447 million. So these are the computations on how we get those values. So if NPV is hugely successful, we get 5.662 million. If NPV is less successful, we get negative 6.556 million. And then the expected NPV, we need to add both of them and then multiply it by 50% because of the probability. So we get the expected NPV at negative $0.447 million. Next question. What is X NPV considering the growth option? So this is another table of Project X wherein they consider the growth option. As you can see, there is a new row highlighted with red font color, the new investment, the Project Y. So in the hugely successful row, we need to consider the new investment Project Y, so we need to add both of them. So in year 0, still remains negative $9 million, and also for year 1, $6 million. However, in year 2, there is an initial investment of negative $10 million for Project Y. So there is a net of negative $4 million at the end of year 2. And also, at the end of year 3, Project Y would generate 20 million. So we need to add 6 million and 20 million, thus we get 26 million. In the less successful row, still the same. Then we get the NPV at 11%. For hugely successful, we get $12.17 million. And for the less successful, it's still the same, negative $6.556 million. Add them, we can get $5.614 million. And then we multiply it by 50% because of the probability. So 5.614 multiply the 50% probability, we get $2.807 million. So the expected NPV of Martin Development Company, if they will consider growth option, is $2.807 million. So again, these are the computation. So if NPV is hugely successful, we need to add the initial investment plus the generation of cash inflows every year. And we also consider the NPV, which is 11%. So if NPV is hugely successful, we have negative 9 million plus the 6 million for year 1 over 1.11. So 1.11 is 1 plus the rate, 11%, 0.11, raised to the power of 1. So we need to substitute them from the formula. Plus for the year 2, 6 million over 1.11 raised to the power of 2, and up to 3 years. Also for NPV is less successful, still we need to substitute them with the rate, 11%, and the annual cash inflows of 1 million per year. So we get negative $6.556 million. For the expected NPV, we need to add both of them and then multiply each of them by 50%. We get the ENPV of $2.807 million. So how valuable is the growth option? To know the value of growth option, we need to subtract the NPV with the growth option less the NPV without the growth option. So the NPV with growth option is 2.807 million less the PV without growth option, which is negative 0.447 million. So the expected NPV is $3.254 million. So Martin Development Company should consider uh, proceeding with Project X with the opening of another investment, which is the Project Y. So they would proceed with the growth option instead of not having the growth option and not proceeding with Project Y.